How are you? Yeah, I am fine. Thank you. Happy New Year. Same to you. Okay, so let's go start out today's session. So basically, today we talk about that climate mapping, how we can use the R and create the different types of climate mapping. Suppose temperature or precipitation or bioclimatic variable. So this type of data, how we can easily make the map using R and also use some R packages. We also try to discuss about that. So let's go. Let me share my screen. Okay, can you see my screen? Okay, so let me open the new code editor, new R script. Okay, so for climate mapping, basically we can use the different types of data for climate related data, such as temperature, precipitation, bioclimatic variable, or wind speed. So different types of climate data we can easily access using the different types of package in R. And for that, we need to use some package. First of all, you need to install when you work first time. We need to install this type of package just one time, not all time, just one time. You need to install. Then you simply import this type of packages. So if you want, you can simply click on the package and install all of packages from here one by one. So simply write, or you can also put the name and also put the comma. Then it will be easily install it. Suppose I simply write the name. Suppose Terra. It's one kind of package. Then suppose I need that geo data. This is another package. Then I put here. I need for GG plot. This is another package. ggplot 2 basically. Okay. And then finally I need SF package. Okay. So this type of package I simply write all of package name together. Just use the comma sign and further simply install. So now just a yes. So now this type all of packages, if I write the name, it automatically install it. So it just need for the one time when you work with that new script, then don't need to install again. Okay, just simply import. So now you can see it automatically downloaded all of packages and also install it in my R Studio. Basically, that the total 4 packages: Geodata, ggplot2, and SF. So this 4 package, we simply install it in our system. Further, we just use it and we try to create the different types of climate mapping for the specific boundary or a specific region of interest. So it's successfully done. We done all of packages successfully installed. And further, we need to import all of packages one by one. We need to import all of packages. So for importing, just put here that library, and then put the package name. First one is that para. Then second one is geodata. Just use the library. and put the package name, geodata library. I put the package name about ggplot 2, this package, and library sf package. Okay. So now just simply run the code one by one. Just simply run. So it imported, then geodata it also imported, then ggplot, and then library sf. So now it successfully imported all of library which I need. So now the geodata package simplify the process of accessing the climate data. For example, we can download the bioclimatic variables from world climate. So if you check from the information about that dataset, basically this dataset called that bioclimatic variable. I simply search here bioclimatic variable, suppose from world climate data. Just a simple run. So then you can easily find out that you can see this data set is also available in the Google Earth engine. Basically, bioclimatic variable data we can easily get from here. So many annual temperature, annual precipitation, seasonal, annual air range temperature, precipitation. So further to check. So let me open this website, main website about the data, and from here you can easily get the documentation. But that world climate. So basically, this data this is the bioclimatic variable. So here we find out that monthly temperature rainfall value in order to the generate more biologically meaningful full variables. So here we find out this type of basically it's the coded. Suppose bio 1, it's mainly indicating about the annual mean temperature. Okay. Bio 2, it's indicating about the mean diurnal range. Bio 3, isothermality. Bio 4, temperature seasonality. Bio 5, maximum temperature of warmest month. Bio 6, so different types of basically we find out the total 19. Bio 19, it is the precipitation of the coldest quarter. So different types of data we also get from here. So further you'll also try to read this thing. You can get the more information about that bioclimatic variable and how we can really use it. So now we try to use this data and further we try to create the maps in RStudio. So let's go. We try to do it. So first of all, you need to download the data and how I can download in using the R. So basically in this case, we are just use the geodata package. We just use the geodata package and then process of the accessing climate data for our study area. So let's go. Just I put here that a variable, suppose climate data, and this variable just I call my geodata package which I already imported. Just call the geodata. So now just I use here the double colon sign, and from here I just call the world climb global. So just I put here the world climb global. So basically you can see this is the function. So download the climate data from world climb version 2.1. So when you download the data, then you have to use this world climb global. So when you download that, you simply use this function. And this function, we need to define our all of argument. Suppose first argument is the var, then resolution, then path. Okay, basically path mainly directory. Which directory you want to import or download the data. So for that, I simply put here the var. I just put here the var is mainly for bio. Okay. Then resolution, I put here the resolution is the 10 meter. And further path. So path mainly you need to define your path. Which directory you want to import this data. Okay. So how I can set the path? So basically, if you write the code get wd, so then you can easily find out that current directory of my data set. So you find out this is my current directory. Okay. And this current directory I want to save the climate data. Okay. Or if you want, you also create the another folder and also use the folder. In this case, I try to use the document folder. In the document folder, I want to store it all of climatic data which I downloaded from World Climb. So just I put here this directory, and further I just run the code. So now it takes some time to download the world climate data. So basically you can see this is the total 47.6 megabyte. Okay, then from this data we can easily access data and create the map. It's working. So it's almost done. Okay, it's done. Okay, so now this data is downloaded and stored in this variable climate data. So just I try to call this variable climate data, and if I just run the code, we find out this type of information. Here you can see we find out that it's one kind of special raster data format, and this data dimension, and here total 19 layer. Okay, 19 layer indicating about this type of information. So if you check the information from this website, this type of information by 1 2 3 4 5 6 7 8 9 10 and 19. So total 19 bands we find out in our data set. So if you check it, we find out. And now if you check all of name, suppose total 19 column name, you want to check it. So for that, basically you can see the names. It show only for this type of name, but I want to check all of name. So for that, just call this column name names, and then call the climate data, your variable name climate data. So just now run it. So we find out you can see all of name. Okay, world climb bio 1, bio 2, bio 3, bio 4, bio 6, bio, and up to bio 19. So here we find out that all of biome information. So annual mean temperature, mean diurnal range, isothermality, temperature seasonality, max temperature, mean temperature. Which data or which parameter do you need? You simply use it and then plot your data. Okay. So in this case, we just try to suppose I want to work for that by one. By one mainly mean annual mean temperature. Annual mean temperature. I want to create the map. So let's go try to do it for that. How we can easily get it for that. So for getting this information, just need to use the name. Suppose okay, let me write the code. So we get this type of name. I want to visualize this name. Suppose I want to visualize the name mean temperature. So for doing this thing, just we need to take a variable. Suppose I put the variable name is that temperature. Temperature. In this variable, I just set one column, mainly by one, bio two. Suppose I need the by one. This information I want to need. So for that, I simply call my climate data because this variable is stored all of layer. So from this layer, I just select for a specific layer bio one. So for selecting this thing, just use here the dollar sign, and you can see it automatically showing all of layer bio one, bio two, bio three, and up to bio 19. So I want to work for that bio 1. Just simply select it bio 1 and then just run the code. And now I want to plot it. I want to plot. So for plotting, just use here the plot. And then I want to plot for this temperature. Just copy and paste here. And further I just set a title. Suppose I put the map title name is that suppose annual mean or average temperature, and you also put here that suppose degree Celsius, or you can also mention about the degree, or if you want, you can simply just I think simply copy the symbol. Suppose I simply search here degree Celsius symbol on the Google, and further just I copy this symbol, simply copy, and this sample I want to add on my map. It will be more better. Just I just paste here. Okay, degree Celsius. So now if I just plot, so now we got this type of map, and this map is for global. We find out the global annual mean temperature for the whole world. We find out this type of map. Suppose I want to work for that another one. So you can see here including the total 19 layer temperatures, maximum temperature, okay, mean temperature. Also you can see the annual precipitation. I want to work for that. So it's the bio 12. Okay. So if I just set bio 12, then we can get that temperature information, annual precipitation. So for that, just I simply write again and simply select the bio 12. So this is the information of precipitation. Just I run it and I put this, it's a annual mean precipitation map. And then further run the code. So now it show the result for precipitation, but it look like that. Further you also write the code to get the more attractive map. How we can easily get the more attractive map. We also discuss about that. Okay, so now suppose I want to work for temperature. So I got this type of map temperature, but this map it show the result for the whole world, but I not need for the whole world. I need for a specific country or a specific district or a specific shape file. Okay, so previous classes I discussed about that how we can easily read a shape file. Okay, how we can easily read the shape file using SF package. Okay, or if you want you can also take the shape file from geodata, because geodata is also provide you the administrative boundary. We can easily get for administrative level boundary, we can easily get it from here. So let's go try to get the shape file from the geodata package. So for that I just take a variable, suppose put the variable name, suppose Bangladesh boundaries. You can put a name as a variable, and I want to access the shapefile of Bangladesh from geodata. Okay, so I already imported the geodata package. So just I simply call the geodata, and from the geodata I want to access a function. It's called the GADM, mainly global administrative. So just I put the function, and now I put my argument. So here you can see it already show you the argument country, then level, then path mainly where you download the shape file. You mention the path. So just I put the country. Suppose I want to work for country Bangladesh. Suppose you want to work for the another country, just write the proper name. Okay. Suppose your country is the Tanzania, so your country name is the Republic of Tanzania. Okay. When you work with the Tanzania, then you also work with that. You write the name Republic of Tanzania. Or you also simply search on the Google, then you also get the more better name. Suppose I simply search here Tanzania. So this official name, Republic of Tanzania. Yeah. So so you also try. Okay, so let me show you your country file first. Suppose I simply copy the Republic of Tanzania and then check what happened. It will download it or not. Okay, suppose I put here this name, Republic of Tanzania, and then further I want to just level. Okay, define about the level. So just put here that level. So I put here suppose level equal level mainly 0, 1, 2, 3. 0 mainly only for boundary, only for Tanzanian boundary find out. 1 mainly division or province of Tanzania. Then 2 mainly district, 3 mainly sub district. Okay, so it's the some more local administrative boundary. So I take the boundary. Okay, and then we need to mention about the path, and I want to keep the same path. Which path I have directory? I just use the same path for my analysis. Just a copy and paste here. So just now run the code and check what happened. So in this case, we find out a problem. This problem is that it show the result invalid. You get the list of country codes. Okay. So let me try only for the Tanzania. Then what happened? Let me check. Tanzania. Now try again. I think now it will work. Yeah. So it's working. Yeah. So now I can say Tanzania boundary is downloaded. Okay. So now I want to display this map only for the boundary. So you can put any name as a variable. It's not a problem. So just I use at the plot, and I need to plot this boundary of Tanzania. Just copy this variable name because this variable is stored the information. So we can get your country boundary. It's a country boundary. Okay. So just put here the country. Suppose I need the country boundary only for the province. So just put here that one. So now it downloaded for the province or division. Okay, then it will be display the data for all of division. So further we also filter this type of division. Suppose I need only for the specific boundary, we also filtering. And now if I just plot it, we can get this type of things. Okay, suppose when you put here the 2, then you also get the more local region. If available, then we can easily get it. Sometime this type of data is not available for all country. So then we need to create. But maximum country, we can easily find out for division or sub-district or district level available. Okay. So now we find out this type of result. I want to create the map for suppose whole Tanzania. Just I put the 0. 0 means that whole Tanzania boundary. Okay. Just I run it and also plot the whole Tanzania boundary. So now after getting your boundary, we just need to crop and max the climate data to Tanzania. Okay. We already create this map. This map display the result for whole world. But in this case, I don't need for the whole world. I need only for this Tanzania boundary, and this boundary is stored in this variable. Okay, so just we need to just need to crop and max. Okay, so crop and max the climate data for Tanzania. So how I can crop? For the crop, just it very easy. Just use the crop function. Suppose I take a variable. Suppose temperature. Suppose Tanzania. I put this variable and use at the crop function. Crop. Okay, crop. And after crop, I want to crop this. This is my full data set, mainly full map. So just I call the temperature because it exported the full map. This map I want to crop with my boundary, Tanzania boundary. It is stored in this variable. I copy this variable name and paste here. Okay. So now it crop. Okay. So just we try to run the code and check what happened. We find out this type of information. So just let me plot and then show you that what happened after applying the crop. We find out this type of result. Okay. In this case, after cropping, we also need to the another things we need to also open. It's called the max. Okay. So if I don't use the max, then we find out this type of result. In this case, it show the whole area. Okay, but I need the result. This result only marks with my study area, only marks with Tanzania. So always after use the crop, you always try to use the marks. Otherwise, it show this type of result. So just try to add the marks. So for the marks, just I just use the same variable. There is no problem. I use the same variable, and I in this variable I try to apply here the marks function. Okay, so just use here the marks with mainly temperature of Tanzania. Just I copy and paste here and mention my Tanzania boundary with stored in this variable Bangladesh boundary. Okay, and further if I just run the code and also display the code, we find out this type of map. Okay, so it display this type of map, and this resolution mainly we find out this type of grid or cell because this resolution is not much good. So that's why we find out this type of result. But when we apply this data for the big study area, suppose I want to apply this data for suppose India. So just I put it that India, and then I simply run the code. So now it is stored at the India country boundary. Simply download it from the geodata package, and now I need to plot for India boundary. Find this type of result. And further, just simply crop and also marks, and then we plot. So now this we find out this type of map, and it show the default visualization. Okay, but you also add the more advanced visualization, then this map look more better. So this is the basic process or basic visualization, okay, for the data, how we can easily crop with our study area. So now we create the advanced visualization. The advanced visualization mainly we convert raster data to a data frame for ggplot. In this case, we are just using the ggplot, and then we try to get the more better visualization. So first of all, we need to convert the raster data. It's a raster. Basically, this temperature Tanzania, it is stored the raster data. Okay, mainly pixel based data. So this data we need to convert data frame, because in this case we apply the plot using ggplot function, and ggplot this function support only for data frame. Okay, so we need to create the data frame from the raster. We need to convert. Okay, so now how I can do it? So for doing these things, just we try to take a variable, suppose temperature df data frame. So now this data frame I convert this raster. This is the raster. So this raster we convert as a data frame. So for that, just use the function as dot data dot frame. Okay, then I call this temperature of Tanzania because it is stored in the raster. So this raster I want to convert as a data frame because I want to apply the ggplot function to get the more advanced visualization. Okay, and now I put here just open the xy equal to put here the true boolean operator true, and also apply for na dot rm, and then put here true. Okay, just run the code, and now okay, so let me just call the temperature after converting the this data. We just make the data frame. Okay, raster to data frame. So now if I just do it, so we can get this type of information here. You can see it show the result. We find out, you can see x y and world climb bioclimatic. We find out this type of result. Okay, so now we just try to change the column name. Okay, so if I just put here suppose column call names, all names, and if I just run it, we find out, you can see this type of column name X, Y, and climate. So I want to change this type of column name. I want to change. Suppose X mainly longitude, Y mainly latitude, and this one is for temperature. Basically, it indicates about the temperature. So these column names I want to change. So how I can change? For changing, just take I just put all of rename. So how I can rename? So just I mention the column names and then I put the new name. Just I make a list and illustrate the new name. Suppose this X I want to display as a basically it's a longitude. I put at that longitude, and this Y is that latitude. I put at that latitude, and further this one is for so for the temperature. So now I run the code. So now it will change. Okay. Now it changed. So now X mainly longitude, Y mainly latitude, and Iowa, this one is for temperature. We simply rename it. Okay. So now we try to plot with ggplot too. So let's go. So after converting, just we need to write the code. Suppose I want to apply ggplot this function. Okay, just we try to run it. There is nothing. Okay. So for that we put at the plus sign, plus, and then we had the geom tile, and put here data equal mainly temperature df. I simply copy and paste here. Okay. And further I put here the AES, and I define here what is the X mainly we rename it as a longi longitude, just copy the same name I put in here and paste longitude, and Y equal latitude, just like copy and paste here. Okay. And put here the fill equal temperature, just copy and paste here. And now just try to run the code and check what happened. So now it look more better. So we find out this type of information, but I want to add the more advanced visualization. Suppose we try to add the title. Okay. So now it just only added the latitude, longitude, and fill. Okay. Just I fill with this temperature. Okay. So with this temperature, so we find out that. So now further, we also add the more information. So further, just use at the plus, and when you define here that scale fill radius column. Okay. So mainly it indicating about that your title. Okay. So further, just write here the scale. It's the scale fill radius C. Okay. So just I put here, and I put here the name equal. We put here the temperature in degree Celsius. So just I put here temperature in degree Celsius. So just I copy this. Just I copy and then paste here. So now let's check what happened. Just run the code. Okay. So now it also added in the listen. We find out some temperature degree Celsius, and we also find out that read scale field radius. So you can get the lot of uh, function regarding different types of color. Suppose we simply search here scale. Suppose scale, then field. You can see B, C, D. Okay, basically three types of color we find out in here. Also I put at the 2 D. So now let's check what types color I can get. So it show that, okay, I think, yeah, so it's the example values. Yes, it's not. I have to put it, suppose, or C. Yeah, C mainly color. Sorry, C mainly color. Okay, fill, scale, fill, breed is C. C mainly color, and then name mainly it's the legend name. So now you find out, and as well as we also try to put the another argument. So for that, just use here the plus, and if you want, simply put the fixed your coordinate. So put that chord, chord, only chord I want to fixed. So for that chord, just use it the fixed. Okay, so now we can get the fixed coordinate. Okay, and you can also look more better. So for that, just use at that. Suppose just put the plus sign and put at that labs. So labs mainly indicating about that title of your map, as well as XY column title. You also mention using the labs. Okay, suppose I put here that first one is the title. So define the title. I define the title. Suppose annual mean temperature in, suppose, India. And further put here that, suppose, X equal, mainly X level we define. Suppose define the X level is the longitude, and Y level, Y equal its latitude. We define it, and now check the code. We find out this type of information: annual temperature in India, longitude, latitude. And if you want, you can also get the more better visualization. So for that, simply put here theme minimal. Okay, just put at the plus sign again, and put at the theme. It's called that minimal. So just run the code. So we find out this type of final result of our visualization. You can also add the more better visualization. Suppose you just create the overlay. Overlay mainly, if you want, you can simply add the overlay as your country boundary. Okay, suppose India country boundary, you also try to mention. Okay, suppose in the country boundary, you also define about all of district, all of things, you also try to add in here. So it also possible. So for that, just take the country boundaries of India. We already create this country boundary, look like that. This type of country boundary we already created. Okay, suppose if you want, you can simply mention your country boundaries, then you also look more better. So how I can do it? So for doing these things, so just we are using are the same, because all of those are the same. We try to put it here. So okay, let me copy the same code. Then I simply change it. Just like copy, because we need to write the code again. Just like copy and paste. So in this case, geom plus geom tile. So it's the same temperature df. Then we define out the x and y and fill with temperature, plus after that we need to mention the another new information. It's called the geom s app. Okay, so basically it call the shape file of your country boundary. So in this case, we put here the data equal. I mentioned here the data. Basically, this shape file data come from this variable Bangladesh boundary. We put in here. Just copy and mention in here. Then fill. In this case, I don't use any fill, any color of my boundary. I put the fill is just put here the fill equal n a, mainly not applicable. N a, not applicable. It means that I don't need any kinds of fill. I just need only for the boundary of my shape file, and boundary color. I choose the color. Suppose uh, black color. Just I put here that black or any color you can simply choose. There is no problem. After that, all of those are the same. Scale fill free is okay. Then color, then port fix left email. So now run the final check what happened for the visualization. Okay, show a problem. Okay, show the data frame. Look the as data frame. Integer length. Error in error 45. Data must be data frame and object 45. Okay, so in this case, this shape file, I think we also need to convert as a data frame because this shape file we don't convert as the data frame. So for that, we just just convert the data frame. Suppose I put the ROI and then I put here as dot data frame and I put here this shape file variable name Bangladesh boundaries and paste here and then put here that xy equal true and na dot rm equal true. So now run the code. There is no problem. And further, I want to apply here this ROI. Just I put here ROI. ROI. So now let's check what happened. Okay, so that GeoMSF problem while the computing set error occurred in the second layer, compute layer caused by error compute layer. Stats required. Okay, stat SF. So stat SF. It's stat SF. So now let's check what happened. Okay, so we don't use the overlay. Why? The error in occur in the second layer caused by the error in the compute layer. Stat is a coordinate mapping must be created by AES as dot data dot frame. So run the code and further just call the ROI. We find out this type of information. So this is that country, GID country, and further let me check what is the problem. So geom sf we just simply call and then call our shapefile variable name. Bangladesh boundaries. It show that error in 45 data must be data frame or an object created by 45 or fully cause the error the previous data frame like object. Okay, so we try to. Okay, I think mistake in here. So this function is only work for the raster. So this function help you to convert raster to data frame. And when you convert the vector to data frame, you have to use the function. This function called the st as sf. Okay, this function you have to use in here. st.sf. Okay, st.sf. And then this type of things is not needed for that. It's only needed for the raster. Okay. So now I just take it RY. So you find out this type of information, mainly st as sf. And further I want to display, just I put at the RY. So just let's check what happened. I hope not will work. Okay. Okay, so now it look more better. In this case, if you check the result, we also find some you can see boundary. You find out the boundary. So to administrative boundary to the add the ggplot when you add. So always you remember that when you apply the ggplot for the administrative boundary, mainly shape file, then we need to use the st as sf. st as sf, then input our shape file. And when you add the ggplot in your raster format data, we need to use this function as data.frame. Okay, this function is only for raster to data frame, and this function only for vector to data frame. Okay, vector to data frame. Then we can easily use it. Okay, if you want, you can also add here that more country. Suppose you want to add the province boundary. So for the province, same process. Just simply change the level. Suppose put here the I put here suppose for one. So now I can get the province. Get downloaded that all of province boundary also for this country of India. So it downloaded. So now we can easily do suppose just run it, and also you can see find out. And further we try to put the ggplot just right on the code. So now it also including all of boundaries of province. So we can also get this type of province also. Okay. Okay. So this is the process we try to apply in here. And further, if you want, you also add the other variable. Suppose you want to overlay, add multiple variable to the map. Suppose I want to add the precipitation also. Okay. For precipitation also, if you want, you can also do it. And further we combine the temperature and precipitation into one plot. It also look more better. So it's the one another kinds of visualization. Suppose I want to display the precipitation and temperature in one layer. It also possible. So for that, just write the code. Let me write the code in here. So first of all, we just take a variable. Suppose I put the variable name is that precipitation, and then this variable I simply call my climate data. I already create the climate data variable. You can check the climate data. This variable is stored the all of climate data. Just I copy, and now I want to work for the annual mean precipitation. I need to select this layer. So basically, this one is for bio. Okay, let me check bio 12 or which one for that. Can check that. Yeah, bio 12 is the annual precipitation. So just we try to add it. So put here that bio 12. So you can see this is the bio 12. Okay. So now run the code. So now I can easily get that bio 12. But this bio 12 data I need for my shapefile boundary. Okay. I need it for shapefile boundary. Same process simply apply. Okay. Same code. So how I can do it? So very easy. Just I copy the previous code. Just I copy. Just I copy. And then paste here. So in this case, I simply change this Just I copy the precipitation and simply change it, because I need to create the crop with my precipitation data and this boundary. And further, I simply call this variable and max with that this data. So now run the code again. Okay. And now we convert to data frame because I want to apply the ggplot. So for that, we just need to convert. So just need to convert. I'll write the comment. So convert to data frame. So for the raster, okay, because this variable is stored the raster information. So these things I want to convert as a data frame. So you also change this variable name. Suppose I put the variable name is the precipitation. Just put the precipitation. It look more better. So now run the code again. So now it converts to the data frame. So for converting the data frame, we just take a variable. Suppose precipitation df data frame, and this data frame I want to convert. So for that, put here the s dot data dot frame. So now it convert as a data frame. I want to convert this data frame for this precipitation Tanzania. If variable name can be anything, there is no problem. And further, I put here that xy equal Boolean operator true, and put here that NARM equal to true, same true. I can just I simply convert to the data frame. Okay, if you check it, this information, and further simply just double click and click to the run, we can get all of information. So we can get this type of things. So in this case, we simply change the column name. The column, basically you can see it show the default column X, Y, and bio 12. So just simply change the column. So for that, just I put here the col names, and I simply copy this variable name and paste here. So now if I run the code, I got all of column name, default column name, but I want to change it. So how I can change it? So just I put this as a variable and create the list. In this list, I simply mention, suppose just mention here the x mainly longitude, longitude, y mainly latitude, latitude, and mainly another one is for, I put it's a precipitation. So now we change the column name. So now run the code, we find out this type of information. So now we try to combine the temperature and precipitation, okay, in one frame. So for combining, we need to combine the data temperature and precipitation into one plot. We just install a plugin. It's called the Password. Okay, if you simply click on the package and install, click on the install and put the package name. It's called the Password. Mainly it's useful to combine the two layer temperature and precipitation. Put at the password and install. Okay, so now further just use a function, suppose library, to import the password. So just write the package name password and then run the code. Okay. So now further we try to make the plot. So just I put hit the variable name, suppose temperature plot, and this variable I simply use the ggplot. Same code we try to use in here. Let me copy from the previous one. So you already define it. So for that I simply copy from here. Just I copy. Okay, if you want it, okay, write the code again. It doesn't matter. So just we define the function ggplot, and I call the temperature data. Okay. So temperature df we already create. You can see this one temperature df. I simply copy and mention in here. Okay, so now it's create the ggplot temperature, and further, okay. So if I just run the code, okay, it also work. But I want to add the more other information. So basically, we need to just use the plot, and then if I just call this variable name in plot temperature plot and run it show nothing. So let's go try to add. So for that, just use the plus sign, and then I want to put here the geom tile, geom geom tile. In the geom tile, we put here the AES and mention here x equal longitude and y equal latitude and fill equal temperature. Just I put here the temperature. So now run the code and also try to plot. We find out this type of